Hello students, welcome to Study It Out. This question is from Chemistry, chapter Thermodynamics. In the question, enthalpies of the formation of some of the compounds are given here. Based on this information, we have to find the enthalpy of the reaction of N2O4 plus 3CO forms N2O and 3CO2. So let's understand this question in detail. Some of the formation of the enthalpies are given in the question. So let's take this is the reaction 1, this is reaction 2, this is reaction 3, and here is the reaction 4. So first reaction is the formation of carbon monoxide. When the carbon, 1 mole of carbon, react with half mole of oxygen, it forms 1 mole of carbon monoxide. Similarly, formation of carbon dioxide, 1 mole of carbon react with 1 mole of oxygen, forms 1 mole of carbon dioxide. N2O, nitrous oxide, here N2 react with half of O2 and form 1 mole of nitrous oxide. In the next one, 1 mole of nitrogen reacts with 2 mole of oxygen, forms 1 mole of dinitrogen tetraoxide. And these are the enthalpies given. Based on the given enthalpies, we have to find the enthalpy of the reaction. So in the reaction, we first look into the N2O4. So in the given reaction, reaction 4 has N2O4. But this is on the product side and we need on the reactant side. So for this, what we can do, we can interchange the position. So we can write N2O4 forms N2 plus 2O2. So when we do, we have to change the energy. It's minus 9.7 kilojoule. Similarly, in the second part, we have 3O2. So reaction 1 has O2 given, but not 3O2. So for this, we have to multiply with 3. So when we multiply this carbon monoxide with 3, energy will also multiply with 3. So based on that, our new reaction will be 3C plus 3 by 2 O2 forms 3 mole of CO. So energy will be 3 times, so minus 330 kilojoule. But as I said earlier, this carbon monoxide is on the reactant side, so we need to change this position to the reactant side. So we write 3CO forms 3C plus 3 by 2 O2. So energy of the reaction is plus 330 kilojoule. Let's consider as relation number 6. So when we add 5 and 6, we can say that by adding 5 and 6, we can write N2O4 plus 3CO forms N2 plus 2O2 plus 3C plus 3 by 2 O2. Further solving, N2O4 plus 3CO forms N2 plus 3C plus 7 by 2 O2. And energy will also be added here. So total energy will be equal to the energy of 5 plus energy of the 6. So it is minus 9.7 kilojoule plus 330 kilojoule. It's equal to 320.3 kilojoule. So we got the energy based on addition of 5 and 6. Now let's see the product of the reaction. In the product we have N2O, and in the reaction N2O is present on the third reaction, and as this is in the product side and this is also in the product side, so there is no change in this reaction. Now we have 3 CO2. So carbon dioxide is present on the second reaction, but it is only for 1 mole, so we have to multiply with 3. This energy will also multiply with 3. It's equal to minus 1179 kilojoule. So we can write this reaction down here. So here I noted down both the reactions. This we can consider as reaction 7 and this is reaction 3. So by adding 3 and 7, we can write it's equal to 3C plus N2 plus 3O2 plus half O2 forms 3CO2 plus NO2. Further solving, 3C plus N2 plus 7 by 2 O2 becomes 3CO2 plus NO2. And energy will be added, so the new energy will be minus 1179 plus 81. It's equal to 1098. Here the minus sign. Now you see, we got previously one relation, this relation. This is the reactant side relation and this is the product side relation. So if we consider this as relation number 8 and this as relation number 9, so we simply have to add both of it. So when we add this relation 8 and 9, so you will notice that this nitrogen gets cancelled, carbon gets cancelled, this gets cancelled. So we get our product as N2O4 plus 3CO forms 3CO2 plus NO2. As we are adding it, so we need to add this energy and this energy. So by adding both the energy, minus 1098 plus 320.3, so delta E is equal to 777.7 kilojoule. So this is the answer of this question.